Our next problem is, in the following diagram ABCD is a square, ABCD is a square, and here also ABCD is a square. APB is an equilateral triangle, so APB an equilateral triangle, and here also APB is an equilateral triangle. In each case prove that triangle APD is congruent to triangle BPC, and here also the same. And we need to find out angle DPC. So angle DPC, this angle, and here also angle DPC, this much angle we need to find. So seems to be both are similar but pictures are different. If we prove for one, remaining will be easily we can prove. Consider the first picture. ABCD is a square, so all sides are equal, and APB is an equilateral triangle. So equilateral means all three sides will be equal. If this is same as this one, and this will also be the same as this, and here also the same. We need to prove triangle APD congruent to triangle BPC. Consider those two triangles first, triangle APD and triangle BPC. So if you prove any three equalities, we can say those two are congruent, and after seeing the picture itself we can come to know that BC is equal to DA, because those are the sides of the squares. So and after that BP is equal to PA. So these two are the sides of equilateral triangle. So for those two triangles, those two sides are equal. So from we don't have information of PD and PC, so we can't equate that. So any angles at least, so we don't have information about these angles. Here we have some notation like APB is an equilateral triangle, so angles at the corners will be 60 degrees each. So the remaining angle, because in a square at a corners we have right angle, so if you lose this 60, the remaining thing is 30 only. So this is 30, here also this will be 30. So here angles are same, so I can write angle CBP is equal to angle DAP. So based on these three equalities we can say that these two triangles, triangle APD is congruent to triangle BPC. Now come to the angle part. We need to find out DPC angle. Since these two are equal, we can call it as isosceles triangle, and their opposite angles, like this one and this one are equal. Then the total angle in the triangle is 180 degrees, which constitutes this 30 degrees plus these two angles. If we consider this as x, this is also will be x, so we have 2x over there. So from this x is equal to 150 by 2, which is 75 degrees. So here x is equal to 75. If this is 75, so at corner of the square here also we have 90 degrees, and at C we have this is 75 and this will be 15. According to congruency, the other side, according to these equal sides, the other side will be also same. So we can say this two sides DP and PC are equal. Since those two are equal, the angles opposite to the sides like PDC and PCD, these two angles are equal. So that means this will also be 15. Okay, angle PCD and angle PDC both are 15 degrees only, and their opposite sides are equal. So this is the isosceles triangle. And now count the total angle. So in triangle PDC, we have total angle 180 degrees is equal to 15 plus 15 plus angle DPC. That's what we need to find out. So this is 30, and angle DPC is equal to 180 minus 30, which is equal to 150 degrees is the angle at DPC, this one. Okay, so for this section it is proved properly, and come to the second section. So here also ABCD is a square, so all sides are equal. And triangle APB is an equilateral triangle, so this is same as this and this, so all these respective sides are equal. And angle at this one, angle at equilateral triangle corners are 60 degrees. Okay, so we need to prove the congruency between APD and PBC. Okay, consider those two triangles first. Triangle APD and a triangle BPC. Both are same only here. So triangle APD is congruent to triangle BPC, you need to prove. So consider those two triangles. So here BC is equal to AD. BC is equal to AD because those two are the sides of the squares, so that is equal. And AP is equal to BP. AP is equal to BP because those two are the sides of equilateral triangle. And one more thing, any angle relation for that? So yes, we have angle relation. So at A, in a square, at A we have 90 degrees, and at B also we have 90 degrees, and in equilateral triangle at B we have 60 degrees, and here also 60 degrees. So from this relation I can say angle PAD is equal to angle PBC, which is 150 degrees. So this is 150 degrees, this is also 150 degrees. So we have three equality relations, so we can say that triangle APD is congruent to triangle BPC. Okay, so proved for the first relation for this second picture. And we need to find out angle DPC. Angle DPC is this one. Angle DPC is this much, that we need to find out. So before finding that one, we should get any reference from remaining things. Okay, so consider triangle PBC, as we considered here also. Consider triangle PBC. So in this PBC we have PB is equal to BC because those two sides are equal, so it's an isosceles triangle. So their opposites angles like CPB will be equal to angle PCB. CPB will be equal to PCB. Okay, so this angle and this angle are same. So since we have 150 degrees at one corner and other two sides are equal, then we can take the total angle of the triangle from triangle PBC, which is 180, is equal to, this is 150 plus those two triangles like angle CPB plus angle PCB, both are same only. So consider one thing, and you will have 180 minus 150 is equal to angle CPB, 2 into CPB. So angle CPB is equal to, here you will get 30 by 2, which is 15 degrees. So here it is 15 degrees. Angle CPB is 15 degrees. Since this triangle is congruent to this one, the respective angle, this is also will be 15. So 15, and here we need to find out DPC. Okay, so angle DPC plus this 15 degrees plus another 15 degrees will constitute 60 degrees, because at the corner of this equilateral triangle we have 60 degrees angle. So from this angle DPC, this is 30, if it goes that side it will be subtracted, 60 minus 30, so we will have 30 degrees at DPC. Since those two pictures are little bit different, so here DPC we got 150 degrees, there we got DPC as 30 degrees, hence proved for those two pictures.